I recently completed the Generation 5 kit and immediately thought of accessories I could make for it. I already have a surface grinder which is great for quickly flattening stock. I use a 36 grit wheel which is fine but leaves a rough finish. Changing it is a royal pain in that it has to be leveled and centered. On the side I saw an attachment with magnets, but at almost $1,000 I thought, well, that's a bit steep. Well, I have several mag switches in my shop that I use for other projects. Searching YouTube, there are several videos on this. However, many use permanent magnets which hold well, but clearing chips, metal dust, and debris is a significant issue which affects accuracy. I came up with a solution, two of them actually, which work well with magnets that you can turn on and off. One is using mag switches, as shown in this beginning video, and the second uses magnetic door locks. Both work great. The Revolution is easy to adapt to using my approach, and for about $300 you have a great surface grinder. As you can see here, it's very easy to release the blade. There's two switches here. After the second one is loosened, the knife basically falls off. The remaining magnetic areas just brush off, and now you have a nice clean surface. Well, to start with the build, I started out with the standard metal. It's an inch and a half, inch and 5/8, I guess. An inch and a half used on all the Revolution. I used a piece, it was about 15 inches long. You may or may not need to go further than that. At least for this demo, I used a standard 4-inch contact wheel. I drilled a 1/2-inch hole. I made a 1/2-inch spacer block just so I wouldn't need as many washers, but you could either put further spacers in or just adjust with washers. The wheels are put on the same they are in the area. This varies from the Terrell build in that the wheel is placed on the second tube, but this works quite well. I think I'll probably go up. I'd like to get a 6-inch or 8-inch wheel for the grinder anyway, but essentially that wouldn't really change the size of the metal that you need for this. The spacers in the 1/2-inch are used to align this wheel to the other wheels so they all run in line. This is the linear trailer that I mentioned in the description. Multiple holes in the bottom. It has to be mounted to something rigid. For this I used socket head, 1-inch 1/4-20 screws. I had to ground down, just put them in a drill and round them over against the belt grinder so that they fit into the holes flush. They can't extend out beyond this area, otherwise the vise won't open the way it's supposed to. So these will actually go in and fit flush with the top surface. So there's, if anything, put them a little bit lower so that there's no problem with the vise opening and closing. If any, the vise in this point is pretty rigid, but once you put the entire assembly together, there is a little bit of side play in this carriage. So the mounting plate I used was a piece of 1/2-inch aluminum, and you really don't need all this amount. This is just what I had on hand. I could easily have gotten away with a piece about 10 inches long. This is about 2.5 inches wide and a half an inch thick. I wanted the vise completely supported, so I extended the aluminum, and although the vise is a little bit larger, it's metric, it fits quite well here. I marked center punch and then drilled all the holes through on this, and then fastened them. So now these are tightened down all the way through. They're 1 inch, 1/4 inch. Does not matter. The nuts are here. They won't interfere with anything. You want to make sure this side on top here is as flush as possible. You want everything to be square and parallel as it can be. Make sure you rotate and run your slide up and down so that there's no obstruction. Now the top part is where the bearing linear glides will mount to. These are M6s. Instead of drilling through all this or interfering with the bearing block, I just drilled this, made this piece to set in here, and the bearing block will actually set to here. Holes are tapped for that. This is 3/8 of an inch. It's important to chamfer these holes so that the bolts are flat. There's no obstruction here. Now this area is attached. It's firmly adherent. You can see though that there's a little side motion here, which I really don't like. I may put an adjustment bolt in there just to eliminate that completely, but a little bit of play in there that hasn't affected the grinding, but I'd like to dial that out completely. Now the bearing area, part of that linear rail, this is a 5 bearing block that can be adjusted for tightness. The way they come from the shop, it's pretty well, these are right on. You want to tap these, the same thing, 1/4. I think these are 3/4 inch, 1/4 20s. My CNC wasn't really working so hot, so I had to do everything manually, and I screwed up on this one hole, but everything's still firmly in place. So the orientation should be here, because your linear rail is going to go this way. Your wheel is here, and you want to, this is to move in and out into the belt, depending upon the size of stock that you have, and make adjustments. It's a very smooth action here. So take it from there. So now I'll screw these down, the same thing, into tapped holes, 1/4 20 tapped holes into here. Again, the bolts had to be rounded over just so that they would fit firmly. It's about a 3/8 inch outer diameter here. So now this assembly's complete. Everything's there. It moves in, moves out. Just waiting for the slide piece, which will come next. Now this is the slide that attaches. There's two round rails inside. This is actually pretty heavy. Probably weighs 4 pounds or so. Didn't bother, but it slides. and it glides very smoothly, and there's no play in this at all. See how nice it is? Now, the part now is where you attach your aluminum with your magnets. The first one I'm going to show you is using the mag switches. These go on quite well. The nice part about them, they switch on, switch off. I've adjusted mine because I also do folders, so I wanted a shorter blade to be held firmly. This will take anything up from 3 inches to about 18 inches, which certainly would cover everything that I make. And that can be adjusted. If you make shorter knives, you could get away with fewer switches, even 2. You need a minimum of 2, but 3, if you weren't interested in your shorter blades, could actually work out quite well. This is the aluminum rail I made. This with 4. This works quite well. These are off now. All I do is turn, and the blade is locked in place. And these catch. I can do it on one end, and that's your magnet on, magnet off. The great part about this is the limitation of using a solid permanent magnet is that you get an accumulation of metal chips and dust, which certainly interfere with the accuracy if you're trying to get a flat surface. And to remove that after every pass or every time you change the blade around quickly becomes almost impossible to do. So this way, once you release these off, it just brushes off, it falls off, the metal falls right off. So I had these around my shop. I use them for fixtures, so I decided, well, I'll use it here. The biggest problem with this is the slots. I have a CNC mill, so I was able to get these pretty close. I still have to file the edges in because the 1/8 inch mill wouldn't make that. But you could make these holes square, anything to fit here. This opening really isn't that important as long as it fits in, because you're putting in 2 screws. I tap these with a 1024, so these screws screw from the top all the way through, and they're held firmly in place. And if there's any downside to using these, that's it, is really getting the holes right. So that can be a real problem. These mags are 95s, mag switch 95s, and I believe each one has a 95 pounds holding power. I tapped the end just to make a handle. The handle was just made on my 3D printer. It's a piece of 3/8 inch all thread, some bolts. Now, once this is done, you bolt this through the holes that are in here. You don't have to change those at all. You just bolt that to this plate. So you attach it to the plate, line it up, punch your holes. What I do is start out flush, and then I drill 2 holes and extended them with a file so that I can fine adjust, I can angle it, whatever I want, so I can get that really right on the button. What fits quite well are these 1024, I think they're a 1/2 inch. And because they fit flush and go up, they could be actually much longer than a 1/2 inch. They could be an inch, whatever. And how they go is this. Get that off your bearings. Put it here. They fit right in these, drop right in without any modification. You don't have to drill or shorten these. There's a little bit of slop, but the idea there is so you have adjustment. You want to make sure everything is square to your belt, and a little bit of adjustment, even 1/8 of an inch or so, will allow you, especially if you start off flush with both ends, to get that right on. I'll attach this now. So there we're attached. So we now have our carriage back and forth. By using the adjustments, I can move this in or out just so I can get it so that it's definitely parallel to where it hits the belt all the way up and down. Just slides on. Nice smooth action. You can move it in or out, then tighten up the nuts. As far as the magnets, there's nothing. That's it. That's not going anywhere. That's essentially 190 pounds of force. So that keeps it so that when you're sliding it past the belt, you're all set. And this works fine in both the vertical and horizontal mode. It's important to put a stop bracket like I did over here, especially if you're going with it vertically, because this thing will just slide right off. This will stop against the carriage and prevent it. So this works quite well. I think the only investment are the magnets. You can get away if they're on sale cheaper. They have a cheaper one, Mag 60. I've never used it, so I can't recommend it one way or another. However, these work quite well. I mean, there's no movement, and you can hold a piece of steel basically from here all the way to there, which is 24 inches. The carriage is 24 inches long. This aluminum here is about 26 inches long. So you've got a huge amount. Now this isn't as rigid as your surface grinders are, just because there's so many moving parts, but it works extremely well. Now I'm going to go into the other modification that I came up across. I made a attachment just for grinding metal parts using Maglock household magnets for doors. And this was a bit of cheaper. I think the total cost was only about $75 for the magnets, as opposed to probably twice as much for these 4 magnets. I'll show that next. So in this situation, pretty much everything is the same. Your base, your mount, your glide is fine. This is, I think, a really good buy. For $100, you get this plus the 5 bearings, and it works very smoothly, and there's no motion at all. As I mentioned, the vise has a little bit of end play, but this situation, this basically just mounts right onto that. This mounts right to the same fixture using the same holes. Here all I had was like 1/8 inch aluminum L, but it's perfectly 90 degrees. And it works well on this. It's a bit lighter, and there's really not a problem with it. And I found the results comparable between the two. I've got about a difference between 3 and 4 thousandths over a 8-inch blade, which for my purposes is plenty fine. So I'll go into detail on how this is put together, the wiring also on this. Now to mount the entire unit together, what I used were, these are 5/16 inch bolts, drilled 2 holes close to the carriage, about a 1-inch space here. It really isn't critical, but in the 2 bolts. So that's about as much aluminum as you want. I got overhangs, just I haven't cut it off yet. This is just a scrap piece from another project. So this is go in your bottom tool holder, where your platen, not your platen, but your grinding base would go in. The top one holds your wheel. So the setup is pretty simple. Your wheel fits in here. If you want, you can put your belt on and tension however much you think you need. Lock it in place. Now you put this assembly here, goes into the bottom area. And then your grinding assembly just slides on, and you're ready to go. This I find very awkward, so I choose to do it in a horizontal fashion. And this allows me motion this way. The slide can move your workpiece in or out closer to the belt. This is the same with the magnets, the same setup. It's not any different if you use the mag switches versus this electromagnet switch. And that's all there is to it.